like something that is going to hurt you right away, damage is immediate, or it can be chronic, something that happens over time and under repeated exposure. Obviously, when it comes to figuring out what the hazards of a chemical are, the acute are much more obvious, the chronic are a little more insidious, and you'll see that in the data as well. It's not nearly as clear for them. So there are a whole lot of different hazard frameworks out there. And there isn't one universal system. We're not going to go into detail on any of them. We just want you to be aware that there are a lot of them. There are some that are geared more toward regulatory systems like your transportation DOT systems. Some are non-regulatory like Green Screen for safer chemicals, which will give you a score for a particular chemical after doing a pretty in-depth evaluation. And you know, again, we're going to touch on some of these, but there really are a lot of them out there. And some things to look for when you go and evaluate those. The terminology may be different in different hazard frameworks. The criteria may not be equivalent. So something that's really bad in one may not be the same level of concern in another. The endpoints may exist in one framework and not another. So things like endocrine disruption are in Green Screen, but they're not in GHS. There's a lot of professional judgment and interpretation of data. And depending on who's doing it, even doing a really great good faith effort, you can come out with different answers in the end. So these are tools, they're not answers. The numerical ratings can be opposite. We'll look at an example of that in a minute. I bet most of you have experienced that already. And when we're not going to get into really digging into how you would evaluate like a formulated product today, but just be aware that some systems sort of screen, meaning if you hit one bad endpoint, then that's as good a, you know, that's the end of it. That's the score you're going to get. Others do more of a weighted average approach and say, well, I've got, you know, not much of this really bad chemical and more of this one. So you're going to see that as you look through the various tools. So we're going to look first at the GHS, the Globally Harmonized System of Classification and Labeling. It is the closest thing we have to a sort of a harmonized system that goes across many different countries and industries. And so we use it in the US under our HAZCOM standard. So that's what's on the safety data sheet. And that's what you're getting when you review your safety data sheet. It is a pretty systematic approach. If you look into the purple book, there's a lot of detail there about exactly how you would go about classifying a chemical. So the way GHS works is that there are hazard classes and then categories. So the hazard class is the different types of hazard, and then the category is how severe it is. So you might have within the health hazard group, you have acute toxicity category 1. That means it's very severe for acute human health toxicity. And this is the information you're going to see in section 2 of the safety data sheet, the hazard class and category that we just mentioned. The pictograms, which I'm assuming you're all familiar with. I had a little activity when we do it for students, but we're assuming you know these as people who are often responsible for the EHS in your facilities. There's a signal word, warning or danger. Danger is worse. And then there's more explanation in the hazard statements and the precautionary statements. Precautionary statements help you try to look about how to do prevention, how to do safe handling, things like that. Again, we're going to go through this as an example. So just a big overview, you know, the safety data sheet is a legal document and it's required for hazardous chemicals. Because they adopted GHS for HAZCOM, every SDS since 2015 is in this new format, and they have gotten a lot better. So if you have safety data sheets in your facility that are pretty old, you would be wise to try to get a new one if that chemical or product has a new one, because post 2015, they really are a lot more comprehensive and they're more consistent, again, using GHS. So a piece of advice. We are only going to look at some of the sections on a GHS today that have to do more with the hazard classification. Those are the ones. So we're going to dive right into it and just go through one safety data sheet. This is a Sigma Aldrich sheet for formaldehyde solution. And just pay attention to whatever is outlined in red here on your screen. And what do you see for the first thing on this one? You can pop up or we'll just walk through it. It's the date, right? If we were in the room, everybody's saying, oh, the date. This one's new, that's good. In the second section here, you're going to see those overviews for the formulated product, if it's a formulated product, or the specific chemical, if it's a specific chemical. And so here, you know, there's going to be a lot of information for most chemicals here, a lot of different categories and information. How do you pick? Well, you might start by looking at these category 1. So here's one, skin sensitization category 1. That's something I'm going to want to look into, because remember, category 1's the worst. Category 1's the worst in GHS, as you see here in the classifications in the upper left. However, if you're very attached to your NFPA diamond, then you know that in that system, 3 is the worst and 1 is the best. So again, remember that GHS, you're looking for 1s as the worst, and in your traditional HMIS or NFPA, then it's the other way around. Always important to point that out to your employees as well if you still have both systems in your facility. So then you get into the more detailed information with the hazard statements and precautionary statements. Again, here's, you know, this is what it says because it said sensitizer. Now they're giving you a little more information about the fact that it would be an allergic skin reaction. Then in section 3, which is my personal favorite section, this is where they tell you what the formulated product is composed of. And if you're lucky, it tells you everything that it's composed of. This is a formaldehyde solution, which has formaldehyde and methanol. So those original ratings that we had under GHS in that first section 2, those are for the formulated product. And now this is starting to tease out, and we'll do more later, about exactly which chemical is contributing to those hazards. So they aren't the same for formaldehyde and methanol, but you can dig down here and say, is it the formaldehyde or is it the methanol that's giving me that particular, for example, the skin sensitizer designation. In section 8, they have the workplace control and time-weighted averages and everything. These are also good indicators in general of how hazardous a chemical is. The lower that time-weighted average number is, the more concern you should have. Formaldehyde's pretty low. In section 9, we get physical and chemical properties. So things like the flash point, vapor pressure, all the flash points, obviously an important safety attribute. And the vapor pressure is important to know whether your employees in your facility are likely to be readily exposed if you take the top off something, et cetera. Vapor density, it's going to tell you whether it's going to sink to the floor or rise up. And that's important for things like methylene chloride that sink down and can create a vapor blanket down low.
Liz, hold right there for a second.
Yep.
So Melanie points out that, you know, she feels like the safety data sheets are now actually worse for environmental information because they don't have things like percent VOC.
That's a really good point. That's a really good point. And so that arises, I think, that arises from the fact that the GHS under HAZCOM does not require the environmental information. So it might have been more helpful before for environmental information and things like VOCs. And because that's not required under HAZCOM on the human health side, that isn't there anymore. I don't know if others have more insight into that, but that's a really good point. This is a sneaky little section, section 10, stability and reactivity. You want to pay attention to that for safety reasons, obviously, and making sure you're not storing incompatible things, but also that hazardous decomposition products. I know a lot of you are trying to figure out whether you have PFAS in the formulated products that you bring in, like lubricants and things. It may not be in the the constituents in that first section, section 3. However, if you see under section 10.6 that one of the hazardous decomposition products is hydrogen fluoride, then you know what? You've got a fluorinated chemical in there somewhere. So this can be a good hint. And I apologize if you can hear banging and crashing. They're emptying the dumpsters in the courtyard outside my office.
Yes, we can hear it, but it's fine.
Okay. And again, then section 11, you get deeper toxicological information. So if you want to try to drill down and figure out, you know, where did that information come from? Where did that score come from? That will help you. The regulatory section is also helpful, and it will you know, help you with compliance, and also can provide some surprising information, which we're going to see later when we look at a safety data sheet. So chemical abstract service numbers, CAS numbers, are your friend when you're trying to do hazard research, because that's the most reliable way to find your chemical. As you all know, chemicals have many, many different synonyms, and different systems, you know, will be able to search in a more comprehensive or less comprehensive way. If you have a CAS number, that's always the best option. Sometimes you want to be looking both for the CAS number and, say, a part of the name of your chemical, because there, as you also, I'm sure, know, there are multiple CAS numbers for one particular chemical, depending on what the commercial mixture is, depending on you know, what the purity is, et cetera. So, and here's your little cocktail party trivia is, what is the last digit in your CAS number? So we can't do this as a group, but I'll just say it's a check digit. So for example, this fake number 1 to 9, you would never have a different digit in the end. That 0 would always be a 0. And if you have, you know, 2 CAS numbers where that last digit is different, then that's an error, because that's simply a check digit for the rest of the numbers. All right, so what are the benefits of a safety data sheet? They're providing good basic product and company information, and they provide mixture information. So where you're concerned about like the flammability, the flash point of a mixture rather than the individual constituents, this is really helpful. They are arranged in a standardized format now, and the GHS criteria is universal. They do aid in your compliance efforts, certainly. They're essential for knowing what to do in an emergency. And it's a really good base, most of the time, it's a really good basic set of information and a starting point for further investigation about hazards. Now, that said, there are also some limitations beyond the one that we just heard about as well. These are based on specific hazard criteria required by law. So for example, endocrine is not included in GHS, so it's not going to show up on your safety data sheet. The GHS is a self-classification system. So even though there are very detailed methodologies about how you determine the classification and the category, it's still done by the manufacturer. And so if they, you know, there is, again, a lot of judgment to be made about these things. And so just bear that in mind. Again, the age, if it's a newer than 2015, you're probably in good shape. They're definitely a variable quality. Some of them are really great, and we have suggested in our system that things like Sigma Aldrich, Millipore are pretty reliable in general, and they have done a good job on theirs. Many of them will not be so great. Some of them will cover a range of products, so it might cover like a whole family of lubricants, for example, and not give very specific information for any particular one. There are often proprietary ingredients, confidential information, and that may require you to go up your supply chain and try to find out exactly what that material is. All right, so actually, back up here, are there any questions on this really kind of whirlwind tour of safety data sheets and GHS? Pam, anything in the chat you want to?
Two things, not really questions. One, Giles just points out you'd like a link to this presentation, and I'll put in the chat a link to all of the materials associated with this presentation in a second. And Bill and Beth just point out that the CAS numbers and the Tura data is a pain in the neck. Right?
Yeah, because there's a weird thing about Excel, what it does with numbers that have dashes in them, DEP has always left the dashes out. And yes, that can be a little bit of a pain. You have to remember not to put the dashes in when you're searching in the Tura chemical list. There has been a suggestion that we also provide a column with the dashes, and I think DEP is going to work on that. But I understand it can be a pain.
All right, Bill, quickly.
I just wanted to say quickly, with conditional formatting, everybody gets the best of both worlds. People who just like to type in the numbers, no dashes is fine. It searches that way, but once the dashes are in there, you can also search on the dashes. So conditional formatting overcomes this issue, then our list looks like everybody else's. But you guys have heard me say that a few times already. Thanks.
We have actually heard you say that a few times. It's not that we're not listening, but it hasn't risen to the top yet.
Sure you are.
All right. So we'll move right along then. And now we're going to dig into what some of the resources that you might want to use are. And as Pam said, did you say in the beginning, Pam, both the presentation and some of the reference materials are on the Turi website, right?
Yes, and I just posted that, and I will be linking to specific documents as we go.
Okay, great. So we're going to go in and dig into some of this information. We have an EHS resource guide, something that I'll keep referring to as a LibGuide because that's what the company that makes them calls them. But it's under resources guide on our website, and this is the link, and Pam has also given you that link in the chat. If you are like me, you're going to want to be kind of cruising around as we do this training and looking at things yourself. If you have two screens, that makes it easy. There are a couple of places where you don't need to see my screen, and I'll let you know that, and you can just kind of go on your own. But this is where those guides are. And we're just trying to make it a little bit easier for you to find additional information. So additional information, what might that be? What is it that you are looking for that you don't automatically find on your safety data sheet? There are some things it doesn't do a good job on, and Pam, make a note to self to add VOC to the environmental list. But neurotoxicity, it covers it a bit, but there's a lot more to dig into there. Reproductive and developmental toxicity, as I mentioned before, endocrine disruption is not part of GHS, so that isn't even on a safety data sheet. And there's some stuff about asthmagens and sensitizers where it may or may not do a good job, and that's one of them where there's a lot of judgment required. And so that's a good one to dig into. On the environmental side, it doesn't always do a great job on the persistence of a chemical and the mobility, fate, and transport. Things like climate change impacts and ozone depletion are things that you may not find on there. So there's a few different endpoints that I would tend to go look for more information, or if you see things of concern on that safety data sheet that you want to drill down and see more information about. So we're going to go right to the guide here. And this is the home page. You see at the top, there's a whole bunch of different tabs, and those refer to different sets of information. On this home page is the basic stuff. So actually, go right ahead. So I just made this bottom box a little bit bigger. So this is general information for chemicals. So these are some of the sites that we're going to go look at today, and some that you probably use. So PubChem is, we're going to talk about in a minute, but it's a government site that has pulled in all sorts of different databases and has a wealth of information. ChemHat, the Chemical Hazard and Alternatives Assessment Alternatives Toolbox, is one that's geared more for work and health and safety, but it's done a great job of pulling in information from other sources. Again, we're going to talk about that one more in a minute. I assume you all have a NIOSH pocket guide, but that is also linked here. And EPA's CompTox Chemicals Dashboard also has a wealth of information. And then the top box here, It's something we're not going to get into today, but if you've already been to other trainings that Jason Marshall has done on P2 Oasis, then you're familiar with it. It is a great tool for organizing the same kind of information that we're talking about pulling out and drilling down into. So if you need a place to put that information, then you should take a look at P2 Oasis. And when we have longer sessions, we can actually integrate that into doing some of the hazard digging. There's also a quick little roadmap, which just gives you the same links that we've already talked about. So this is the Beyond the SDS page. If this is easier for you to use, it has some of the basic links on it as well. This one up as well. So again, ChemHat. And I assume that you all have just a quick link on your desktop already to the Tura list of toxic hazardous substances, but if you don't, that link is here as well. As we mentioned, reliable safety data sheets come from places like Millipore Sigma, and that link is here, PubChem. The ECHA information. So the European Union has a wealth of information that's reported by manufacturers under their registration system, the REACH registration. It can be a little bit difficult to dig down into and find that information, but there is a lot there. And they have some good basic information on chemicals at the top level as well. And they will have harmonized classification and labeling, for example, on those sites. And somebody already mentioned Cameo. And I know that has some good basic information on it. And I know that a lot of facilities use that. All right, so we are going to leave the LibGuide here for now, but just know that those links are all there. And on the other tabs are many more links that will be helpful, again, as you start to drill down and look for additional information. So today we're going to use ChemHat, chemical specific current safety data sheet, and PubChem. And also, just because we're at the Tura program, you're going to take a quick look and see if something's on the Tura list. So ChemHat's the first one. And I am going to attempt now, because I shared my whole screen, I hope. I'm going to, can you see that?
Yep.
All right, perfect. So I'm going to just walk through doing something with ChemHat, and you get to watch. Oh, actually, I take it back. Actually, I'm going to show you something else first. All right. So instead, we're going to talk a little bit in general about ChemHat, and then we're going to drill down into it in a couple of minutes. So this is an example, formaldehyde, the same thing that we just looked at as a safety data sheet, but I'm going to point out a few things that you should pay attention to when we do go use it. So right up at the top and the upper right of that left-hand screen, there is a little set of colored diamonds from red to green. And those represent either strong effects or strong evidence, or both, on the red, to weaker effects or weaker evidence on the gray. And so when you look at the diamonds below, where this is giving you very summary information about acute effects, for example, you see a yellow one, then orange one, a yellow one, that can relate either to the strength of the evidence or to the strength of the effect, and sometimes both. So that's good to know as you kind of cruise through. If you see a lot of diamonds like you do on this one, a lot of endpoints, which ones do I look at? Well, I'm probably going to start by looking at the red ones, so you see cancer here for formaldehyde, for example. But this is a great system to pull in some basic information. It pulls it from the Pharos database of chemicals, and I don't know if any of you are familiar with that, but that system pulls all sorts of authoritative lists, many, many authoritative lists, including the Tura list, into a Pharos database that's available by subscription. But ChemHat pulls from all of those lists. So it will have good information on chemicals that are well studied and are toxic because they're on a lot of lists. It won't have as much information on a chemical that's not well studied, that's newer, or that isn't already on a lot of authoritative lists, or is safer, and so does not on a lot of those authoritative lists. And we're going to, again, drill down. One of the other advantages is that you see the little green dot and the data sources next to acute, next to chronic. That is where you can see where did they get that information from and how am I going to drill down. There you go. So this is the data sources. And I pulled up this one. This was so for the chronic. So you see asthma trigger. So that's something I'm kind of interested in knowing. Why do they think that this is an asthmagen? This system, the ChemHat system, is rather precautionary. So they're going to assume that there's a problem if there is some evidence for it. So I'm going to look down and see who has actually said that this is an asthma trigger. And then I'm going to go dig in. AOEC is a great resource for that. So I will then go to my LibGuide, get the link for that, and try to drill down and see what kind of evidence there is for that. So that's a quick look at ChemHat. Again, in a minute, I'm going to pull it up and we'll do a chemical. But I just wanted to also mention PubChem. PubChem is an incredibly comprehensive resource. And again, it has pulled in, if any of you used HSDB in the past or any of the other tools that the government was providing, that NIH provided, they have all been pretty much pulled into PubChem. It provides this kind of information. The ones that we're going to look at today around the hazard, it has great library of structures for chemicals, if that helps you. Lots of different names and synonyms and identifiers. It'll give you those similar CAS numbers, the physical properties, chemical properties. It gives you some somewhat dated, but some information about use in manufacturing. It also provides tox and safety data as well. And again, it's because it's pulled in HSDB and some other resources, it has some pretty detailed information there. So the disadvantage is that it can get a little bit overwhelming.
And Liz, if you go back just really quickly, one of the things that I always find interesting are the associated disorders and diseases. So if you are using a chemical and you know that somebody is experiencing something, this might give you an indication of whether or not this chemical might have something to do with it. So I find that interesting.
Yeah, great. And there's a ton of other really great information here too. It's again, it can be a little bit overwhelming. So again, the things that we are likely to use today or that you're likely to go to first are things like the structures, the names, use, safety, and the tox data. And again, it's well referenced as well. So you can go drill down and find out where that information came from. Just because with the TUR program, here's the TUR list of toxic or hazardous substances. So if a chemical has been added more recently onto the TUR list, or if it's been designated as a higher hazard substance, TURI may have additional information that's already been pulled together about that chemical. And so that's also a good place to go for additional information. We have EHS summaries for anything that the Science Advisory Board has looked at, for example. So if you go to this list and you see it's a higher hazard substance, then go and see if we have good hazard information already pulled together for you. And yes, you're going to have to do it without the dashes for today, though. So there's also a sheet that Pam referenced that's on, it's both on the LibGuide and on the training site, which is just a summary again of these links. We don't want you to have to go search for links. Although I will say that also Google is your friend when you go to looking into the hazards more deeply. Google has a ton of great information available that you can get just by putting in the search terms. But here are the links, and so hopefully that helps you a little bit get to where you're going. All right, so now we're going to jump right into this first activity. I was just so eager to get to this safety data sheet, you just can't stop me.
That's great.
So we're going to walk through a safety data sheet and ChemHat. And I guess we'll start with the safety data sheet, but we're going to do a chemical called diethyl phthalate. I don't know if any of you are familiar with that or not. It's a low molecular weight orthophthalate ester, as you see in the image that I took right from PubChem. It's a plasticizer, also used as a solvent, and also used in fragrances and cosmetics, and a bunch of other products as well. And you'll, in a minute, when you get to the activity you're going to do, you'll see why we picked this. So let's look at the safety data sheet and then ChemHat. So I have a bunch of questions I'm going to ask you, but I want you to ignore my screen. If you only have one screen now, please bring up that diethyl phthalate safety data sheet that Pam gave you the link to. And that's what I want you to look at. And then I'm going to ask some questions while you're looking at that sheet. And you can just kind of unmute yourself and pop up with an answer. Again, be easier in a room, but we'll do it this way. All right, so hopefully everybody has that sheet in front of them now. So the date, is the date new enough for us to think this is a good option?
Go ahead and unmute yourselves. Yes, Kyle says, okay.
Yes.
Or do it in the tab, in the chat. Good.
Yes, yep, 2022, we'll take it. Going to jump down to section 2. So what's the classification for diethyl phthalate according to Sigma Aldrich? Pam's going to start calling on people if you don't volunteer.
Oh, I will. I will.
Where is the link you want us to connect to?
So I put it in the chat a couple times, Kurt. So it says session C links and resources. It's a PDF and everybody should open that up. Sometimes it asks you to download it or something, but do open that up because we'll be referencing that quite a bit. So Liz, Kyle points out short-term acute aquatic hazard, category 3.
Yep. So category
Laura
3
said
means,
too.
yep. Category 3 means it's not the worst thing in the world, but this is something you should pay attention to.
And Scott just put a link for the actual safety data sheet from the Sigma Aldrich website. Thank you, Scott.
Great. Yeah, so the rest of section 2 here, we've got the GHS precautionary statements and hazard statements. So what's a precautionary statement that may relate to the questions we're going to ask? Now we're just going to move along. Avoid release to the environment, which is pretty clear if it's harmful to aquatic life, right? So move along to section 3. Here we have the composition. This is a Sigma Aldrich chemical fact sheet for specific chemicals. So there aren't any other ingredients. Although if you buy this chemical from a commercial outfit, it might have other things in it like stabilizers or some other constituents. But in this case, we've got 100% of diethyl phthalate. It gives you the CAS number and gives you a classification for that chemical, which again, because this isn't a mixture, is the same as what you just saw in section 2. All right, so then turn over. I can hear your pages turning. We're going to go over to section 9. That's on page 5. So what can you find here? Can you find the flashpoint? Somebody call it out.
170
degrees.
70, yeah.
Excellent. All right. And the vapor pressure?
19.
Yeah, 19. And I'm still not great at some of these metric units, but it's not far off from millimeters of mercury. So I know it's got a high vapor pressure. I know it's going to evaporate readily.
So actually, Liz, people are like, bam, putting it in the chat. So this is great.
Right. See, I'm not watching the chat. So
Yeah,
thank you, Pam.
It's awesome.
So section 11, turn over to page 6. So section 11 is the tox concerns. So again, we didn't see a whole lot in terms of hazard classification. So maybe we want to just kind of look here and see what we see. And because we're going to dig into this one a little bit more later, I want you to look at the respiratory or skin sensitization. So what did they do site one test there? And did they find any results of concern?
No.
Says negative.
Negative,
Negative.
right. So that means they are not concerned about skin sensitization for this particular chemical.
Jean points out skin irritation / corrosion.
Mhm.
And then there's, Al points out there's an LD50 for dermal rat. So
Yeah.
avoid taking baths in this material. Good point, Al.
And that LD50 at 5,000 mgs per kg, that's pretty high. So if you don't have a tox background and don't know whether that's high or low, it may not help you. But if you do, then that's telling you 11,000 mgs per kg. Okay, you're really dosing that animal, and there's still, didn't seem to be, or that's where the LD50 is, but that's a high dose.
All right, good.
All right, so section 12, ecological concerns. All right, we saw earlier that it was toxic to fish. So what kind of additional information are we getting out of section 12? How much should I worry?
Go. All right, don't make me call on you.
That's fine. You're seeing specific aquatic animal tests, right? Like Daphnia, you're getting milligrams per liter. It's pretty high, but remember an LC50 or an LD50, that means half of the animals died. So these are not like when it starts to hurt. These are when it's killed half the animals.
And Liz, Jennifer asks if you could touch upon mutagenicity.
Sure. Mutagenicity. So this back in the tox effects, it did mention germ cell mutagenicity. So they have a bunch of different tests. For the most part, the mutagen tests are going to be in vitro, meaning they're like cell tests or not done on animals. And they will, something like the Ames test is really common, may or may not actually elicit a result even when other tests might. But there's lots and lots now of different mutagen tests.
And Shannon makes a really interesting point. She says, but a single number doesn't help. If I'm traveling 40 miles per hour, am I speeding?
All right. Well, you know what? When you take the P2 Oasis training in a future time, you'll see that they help you kind of classify those things. If you go back to the GHS book, it will also help you classify that. So you can tell whether you're speeding by going to that purple book and seeing what the criteria are for the different levels.
Bill, you
So
have a question?
just one more quick thing, the endocrine disrupting properties under 12.6, it just says no data available. And why did I go look at that? What's the name of the chemical?
Phthalate.
Yeah, thank you. It is a phthalate, and it is a low molecular weight phthalate, but it's still an orthophthalate, and that makes me suspicious that there might be some endocrine issues. And so no data available doesn't really give me any information about whether it's a problem or not. All right, any other quick questions on that?
The only thing that I wanted to share, Liz, is that I know that having a single number sometimes can be a little bit puzzling, but when it comes to toxicity testing with aquatic animals, it's not really. And there was a company that I was doing work for back in the early 90s. They were a tannery. They were located pretty close to the Charles, and their LD50 for Daphnia was a really, really high number, but they weren't using any really toxic chemicals, but they were using a vegetable oil and tanning. So what was determined from that vegetable oil, if it's in the water at 0.5% or greater, you're going to have a high LD50. So you can look at those numbers and learn things like that from them.
Yeah, that's a great point, Bill. And it's also a good point that this is all very complicated, and people make their livings doing just those kinds of analyses. And so, going to someone else for assistance is not a bad thing when you see something that you're concerned about and don't have a whole lot of information or confident information. So good example. All right, so now we're going to go pull up ChemHat for this same chemical. So I'm going to start by typing in diethyl. And a trick of ChemHat is that you can't type in the whole name or the whole CAS number and then push search. You actually have to watch things pop up as you type. So here I see 3 entries for diethyl phthalate, 1 for metabolite, and that's because they're pulling this from different sources. They've got different CAS numbers. Those are different commercial mixtures, whatever. So this one that says primary CAS RN, I like that. I'm going to pull that. So if it says one that says primary CAS registry number, that's a good choice. So here we are, and I now have diethyl phthalate here. And I'm looking around, so do I see any reds?
No.
Yes.
Not under health effects,
Oh, yep, there.
right? But so let's stick with health effects for a minute. So then I'm going to, we just looked and said, it looks like it might have some, or we're concerned about endocrine properties. Remember these gray ones, like the toxic to humans and animals, or the cancer, those are gray because either it's got some remote risk or because there just isn't much information. So let's actually pull up the data sources for the chronic information. All right, so here we are. We've got all our data sources for those diamonds and notes that they had there. So cancer, group D, not classifiable as to human carcinogenicity. All right, so there is no data that says this is a carcinogen. It's just not classifiable. We don't need to worry too much about that. Endocrine disruption. Okay, so what have we got? We have the European Union, ChemSec, which is a SIN list. So that's an NGO that puts together lists of chemicals of concern. We have the TEDx, which is no longer an active effort, but there is a historical list of potential endocrine disruptors, which was really well researched at the time. And then UNEP and ECHA both have good lists. So ECHA has a pretty good list. And that's the same thing that's noted up here at the top, the EU. And this says category 1, in vivo evidence. So we're not going to do this together, but I did drill down on this myself. And actually, that's a precautionary way of describing this, because it's actually under assessment. And its original assessment was category 3, which in the EU system means we're suspect, but we don't actually have any evidence at all. And so it's under assessment now. So actually, there isn't any really strong evidence. It's mostly about the fact that its name is diethyl phthalate, and there's a lot of evidence for many other orthophthalate esters. So I might not be quite as concerned, but it's certainly something to pay attention to. And you notice it said no skin sensitizer on the SDS. But here now I see it's got a little diamond for that. And that is referring to the Japan GHS system. And as some of us at Turi have been looking through this in a little more detail, by the way, Karen Thomas, who is helping us out do some of this work and has been working on the LibGuide, spent a bit of time with this Japanese GHS system, and she's a great resource if you need additional help. It has some evidence, like one study out of maybe half a dozen that showed some reaction, even though they gave it a category 1. So again, it does pay to drill down, and this system, this ChemHat, is going to be pretty precautionary. If it's on anybody's list showing that it might be a concern, it will probably show up here. So again, there is a red under persistence down here. And when I look there, it's on a Canadian list that, again, we found is pretty precautionary. So if anything has a decent residence time in any media, then it will show up on this list as persistent. So if I'm concerned about aquatic toxicity. If it turns out I'm going to be discharging this directly to a water body, like Bill was talking about the Charles River, then I'm going to want to look into this a little bit more. All right. Any questions on ChemHat? Before we slip back and let you guys do your work?
So, people have been, making a few comments about the safety data sheet showing there's a component that is carcinogenic. It also indicates that that this formulation, this diethyl phthalate, is readily biodegradable, which impacts how you think about the environmental impacts. So people are diving in. I just want to remind folks to access the links and resources document that I've shared a couple times. If you can't, for some reason, grab it off of the chat, you can go to our website, and I've included the link to our website where you can get that information. So please do that for the next activity,
which we are going to start right now. All right, so now Pam's going to be breaking you out into groups, and you're going to do your own little investigation. So there's a new fall scent, and in my company where I make soaps and body washes, I think that the adolescents and teens really love this brown sugar smell. So I have found a new fall scent, Brown Sugar by Wellington Fragrance, and that safety data sheet is available to you, as Pam said, on with all the other materials, and the link is here as well. So we are going to have you first, we're going to break you out into groups, and step one, you're just going to look through the manufacturer's safety data sheet. Is there missing information? What are you mostly concerned about? And you're just going to take a few minutes to do that, like 5 minutes, and then we'll come back together, and you can say a few things about what you find, and note anything that might be surprising. And then we're going to send you back to do the rest of the activity. So,
right.
Yeah.
And I'm going to break you into groups of 5 or 6. So just dive right into that first step, looking at the SDS and kind of quickly seeing if there's missing information or things that you're particularly concerned about. We'll give you 5 minutes for this component of the breakout.
And remember to look through the whole thing, or at least all the sections that we just talked about. It's not that long a safety data sheet, so you can break it up amongst yourselves if you want.
Great. Okay, I'm going to send you on your way. So please join. You should have an invite to join now.
Oh, I do too.
Well, you don't have to.
I'm not going to, because then I have to stop sharing.
Okay, so I have a couple people who haven't joined yet. Andrew, are you able to get into your breakout room? All right, I'm going to stop recording. I forgot to start. Okay, I have remembered to hit record again. So welcome back from your breakout rooms. It looks like there's a couple more people who are going to suddenly be dumped back into the main room in 9, 8, 7 seconds. How'd that go for you all?
Great.
Good.
Being recorded.
Good, good. All right, here they all come. Welcome back.
Great to be back.
All right.
One of
Liz.
the things we found is that the SDS didn't have an endocrine disruptor, but did have it listed as an endocrine disruptor. And it has very low LC50s for Daphnia and flathead minnow. So there's some extreme water toxicity associated with this material, as well as a lot of the human factors too, as well.
So maybe not a good body wash, huh?
Probably not a good body wash. Yeah.
We found
So
some
that's-
conflicting information about carcinogenicity. PubChem indicates it's not carcinogenic in humans, but I think the SDS indicated it was an OSHA carcinogen. So there's some conflicting data out there.
Well, it says carcinogen confirmed in animals, but not in humans.
Right.
Well, the Turo list had it listed as a carcinogen.
Yeah.
It's probable if you look at all of them, but again, it's carcinogen in animals, but it's not been proven in humans.
And what
Good
happens
point.
in PubChem?
PubChem has it.
Correct me if
PubChem
I'm-
has it.
Go on, Giles.
Yeah, sorry, PubChem has it as possible human carcinogen.
Right.
ChemHead has it as cancer causing.
So in PubChem, you get a whole bunch of data, right? You get access to all kinds of research. So there will be conflicting information in there, right, Liz?
Yeah, and especially around the carcinogenicity for DEHP, it was identified really early on as a potential carcinogen, and then data that came out later didn't show as much. And so it has kind of waffled on different lists. It's why it was originally on the Tura list, was because it was identified really on as having those kinds of issues. So now I think it's like a 2B and IARC, right? And everything. So it's still a little bit waffling, but it has other issues, right? What other issues did you find with DEHP in particular?
Well, under section 10, stability and reactivity. I'm sorry.
Go ahead, Bill.
Under 10.1 reactivity, this is some important information. Forms explosive mixtures with air on intense heating. A range from approximately 15 Kelvin below the flash point is to be rated as critical.
So we certainly want to be careful. Some of the
That's
other
right.
groups want to
Yeah, you want to be careful how you're formulating this stuff. You don't want to be putting this into high temperature mixtures. It's going
Right.
to break it down anyway, but still.
Yep.
Is it have a
What-
turtle?
When I looked up the SDS, and then I went to another group and I Googled it, and it comes up that it is used in plasticizers that are have common contact to foodstuffs. Another use that I thought was really interesting is that it's a solvent in glow sticks.
Yeah.
I didn't know that.
Hmm,
Great.
Interesting.
Other groups want to report back in what you found?
Someone we haven't heard from? Let's see. David, go ahead.
I was gonna say in the if you go, there's a link. If you go to ChemHat, no, it's PubChem, I believe. ChemHat. There's a link to the CDC website, and they list the uses of it, and it's used in just about everything.
Yeah.
It's crazy. It's all over there,
Yeah, and it's not used.
Sheets, everything.
Yeah, it's not used as much. At one point, it was the workhorse plasticizer, period, in everything, in PVC everywhere. And it's not so much because of the concerns around endocrine disruption and reproductive, effects and all that. So it has been replaced by many, many other phthalate esters, some ortho, and then some like that one that you saw in the section 15, the DOTP by a terephthalate. So they have tried to substitute with other phthalate esters from DEHP.
The one good
And
thing is-
so
I'm gonna break in, everybody, sorry.
Yeah.
We've got a minute left, and what I'd like
Yeah.
to do is give you a chance just to kind of show your last slide, because there's some additional resources we just want people to see. And then this session goes until 10:30. However, we are, and so if you need to leave, you're welcome to leave. But if you want to stay, we definitely would love to continue this conversation. So Liz, if you could just share your slide quickly and show that kind of additional resources slide. Because it is 10:30, so I want to let people who, keep going.
Yep. So yeah, we were just going to do a little bit of wrap up and just mention that there are some certainly benefits for doing this kind of deeper research. And I can see that you all found a whole bunch of really interesting stuff and some conflicting. And so, we're happy to help if you need help sorting some of that out. But there is a lot more information to be had beyond than what you just find on the SDS. And there's a lot of stuff that you will find in other products you get that are proprietary. Contacting your supplier is important. I think I'd rather hear from you guys. Is that enough, Pam, for wrap up, and then we'll.
Could I
Yeah,
just share one more thing that I found on this SDS that I think is real important?
yep, let me just hold on, and I just want to say one more time, if you all need to leave it's 10:30, don't be shy, but if you want to stay, you're welcome. Okay, go, Bill.
Section 11.1 under reproductive toxicity may damage the unborn child, may damage fertility. So these are things that specifically when I was in industry, I would look for this because if someone is expecting or working with fertility, then I might move them into a different part of the plan or make sure they're adhering specifically to all the PPE requirements. Another thing that you see in this section sometimes is teratogenicity, which sometimes can cause testicular atrophy in men. So that was another one that I always look for, these two types of things, because they're kind of hidden. And somebody might think I can work with it and everything be okay. But if a woman's pregnant, she's working with this stuff and not properly protected and breathing it in, et cetera, then she could damage her unborn child. So I think that's very important.
I agree, Bill. You know, the reproductive toxicity, developmental toxicity is super important. And, you know, we hope that you guys as TUR planners can help them find safer chemicals instead of just having to move them to a different part of the facility. But I realize sometimes that's not going to be an option. For the people that are still on, are there any particular resources that you thought were particularly helpful?
Well, the Chem Hat I found very helpful.
Good.
One of the sites I do use is CDC. That can be helpful and not so helpful because it gives you a ton of information you have to run through, and a lot of stuff probably wouldn't be applicable.
Right, and ChemHat was designed as a communication tool. It was
Yeah.
designed as a tool that you can use to share with workers to help them understand the relative hazard of the chemicals they're interested in. And so that's why we all, I think, find it really useful. It you know, breaks things down and kind of makes it really easy to understand and digest. And it has its own limitations, of course.
PubChem was not designed as a communication tool. It was designed as a repository for a vast amount of information.
I found myself getting very distracted in PubChem.
Yes.
Like I ended up reading about how, you know, there's the DHP in 16 out of 16 vodka samples and whatnot.
Interesting.
Well, Liz, I think it would be helpful at some future session talking about this kind of topic, you know, maybe to kind of do a deeper dive and guidance in, you know, going through PubChem and, you know, how to really interpret the information that's in there and you know, make use of it.
Yeah, and John, that's a really good point. So we actually offer this training in a much longer format, at least once a year, typically in the fall, sometimes in the spring as well. We do it because we want to also train students who are working on research that we're doing, so that they can understand what, you know, what hazards we're concerned with and why. And that's a longer format. And when we do that in person, there's lots of opportunity for that deep dive. So I did put in the chat just suggesting that people keep an eye out for that if they want to do that deeper dive.
Oh, good.
Yeah, it's a good point.
Yeah, I would just say
Well,
that
guys, I'll see you this afternoon. It's been
All right.
great.
Bye, Bill.
Bye.
I would
Thank
just
you.
add that these are
Thank
great
you.
things to bookmark. So great
Thanks,
job.
Liz. Nice job.
Yeah.
Yep, good. All right, I'm gonna.
Yeah, and Sherry got at